So this is just some examples, a real-world example of when you might use a geometric sequence. Serena Williams was the winner out of 128 players who began the 2003 Wimbledon Ladies Singles Championship, and her sister are still playing. After each match, the winner continues to the next round and the loser is eliminated from the tournament. This means that after each round, only half of the players remain. So this is the type of sequence that we would call geometric. So if the first term there was 128 and then half of them are eliminated, then at the second term there's 64 and then half are eliminated. So our third term would be 32 and then half are eliminated. So 16 would be our fourth. So this is known as a common ratio. So you can take a term and divide it by the previous term. 64 divided by 128 is 1/2. And then 32 divided by 64 is also 1/2. 16 divided by 32 is also 1/2. So all of these ratios are the same, and that's called a common ratio, and we call that R. And we've used this already, so you should be familiar with that. Here's a graph of that tennis situation. As you graph it, you can see that it starts to decrease rapidly at first, and then it kind of levels off. This is an exponential function model. So geometric sequences have exponential models or graphs that are exponential. So you can think of these as an exponential function with sequential natural numbers as the domain. So here's an example where we're just going to identify, and since we've already learned about arithmetic sequences, the question will be, decide whether or not this could be geometric or arithmetic, or maybe it's neither. It could be one of those three things. And if it is arithmetic, find the common difference. If it's geometric, find the common ratio. So our first sequence is 100, 93, 86, 79. So remember that if it's arithmetic, our first differences will be our common difference, and they would all be the same. If you find that it's arithmetic, then you don't have to check to see if it's geometric, because it's only going to be one or the other, not both. So this is arithmetic, and our common difference is going to be -7. Okay, here's another example, 180, 90, 60, 15. So if it's arithmetic, we would have the same differences, but we don't. We have the differences of 90 minus 180 is -90, 60 minus 90 is -30, 15 minus 60 is -45. We do not have common differences. So now we're going to check the ratios. When you do the ratios, you take a term divided by the term before it. So 90 over, let me write these out, 90 over 180, that simplifies to 1/2. Oh, there it is. And then we check 60 over 90. 60 over 90, that simplifies to not 1/3, it simplifies to 2/3, because 3 goes into 6 2 times and 3 goes into 93 times. And then we check 15 over 60. 15 goes into 15 once, and 15 goes into 64. So we get the ratios of 1/2, 2/3, and 1/4. This is not common either. So this is not arithmetic, it's not geometric, and those are the only ones you've learned. So we have to say that this is neither. Okay, here's another example. Determine whether this sequence could be geometric or arithmetic. So let's check our first differences. And we find -4, 0.2 minus 1 is -0.8, and then 0.04 minus 0.2 is -0.16. You'd want to check this with a calculator, of course, but we did not get common differences. So now we check the ratios of one term divided by the one before it. So let's write that out. Let's take the second term and divide it by term 1. That would be 1/5. Just leave it like a fraction is fine. Or you can change it to 0.2. Second term, or the second ratio, would be 0.2 divided by 1. And that is also 1/5, but you probably would get that on a calculator as 0.2. Now let's check 0.04 divided by 0.2. So I'm going to get my calculator out, and I go 0.04 divided by 0.2, and what do you know, that is also 0.2, which this wrote as 1/5, but that's fine. Either way, we have a common ratio. Therefore, R is equal to 0.2, and this is geometric. This is just another example for you to try, so pause the video, see what you get if this is arithmetic or geometric. Okay, so you should have found that there was common differences, so therefore this is arithmetic with a common difference of negative 0.4. Here's some examples from your worksheet. They're not too tough. Let's do number, let's do number 3. So in number 3, the first thing that I do is check if I have common differences. So I take 60 minus 10, that's 50. And then I take 110 minus 60. That's also 50. So you're going to continue. If you get 50 for all of the common differences, then you'll say it's arithmetic with a common difference d equals 50. Let's try number 4. Common difference. So that means take negative 10 minus 5. That's negative 15. Then I take 20 minus negative 10. That's the same as 20 plus 10, which is 30. I don't have common differences. So I'm going to move on to ratios. So the ratio would mean I would take the second term and divide it by the first term. That's negative 2. Then I'll take the third term and divide it by the second term. That's also negative 2. Now if you see a pattern and you think that it's going to be that, check it with all of them. So then I have negative 40 over 20. That's also negative 2, so it's looking very good. Just a couple more to check. And it looks like in all of these cases, the term divided by the term right before it, the previous term, every time the ratio is negative 2. So number 4 is geometric, and the common ratio r is equal to negative 2. Now there probably is at least one of these on here that is going to be neither. All right, so now that we know how to tell if we have a geometric series or sequence, now we're going to work with those type of sequences particularly. So we already have worked with recursive rules for them. You multiply a previous term by the next term, and that gives you the next term. But we will most often use the explicit rule because then you don't have to know the term right before it in order to keep going. And here is that rule right here. A sub n, which is any given term of this sequence, is equal to the first term times r, the common ratio, to the exponent to the power of n minus 1, where n is the term that we're looking for or given. Let's practice. So here we have the sequence 3, 12, 48, and 192. Our first step, and they tell us that this is geometric, so I don't have to check if it's geometric or arithmetic. They tell us it's geometric, so I have to find the common ratio. So to do that, I take term 2 and divide it by term 1. That's 4. And then I keep going to double check that this is going to work for all of them, that I didn't make a mistake. That's also 4. And I can check and I'll get 4 for all of them. So our common ratio is r equals 4. Once you know the common ratio, we're going to write the general rule for geometric sequences, which you should write down on your notes and tape it to your wall and memorize it. And that is that a sub n is equal to a sub 1, which is the first term, which is 3 in this one, times r, the common ratio, which is 4, to the n minus 1. Now n is what term they're looking for. They're looking for 7. So n is going to be 7 for this problem. That'll change for whatever they're looking for. So a sub 7 is equal to 3, that was the first term right here, times 4 to the 7 minus 1. Now order of operations is extremely important here. If you multiply the 3 times 4 together and get 12, you'll get this problem wrong. You have to first work with the exponent, 7 minus 1. That's 6. So our first step is to rewrite this as 3 times 4 to the 6th. Second step is to do this, 4 to the 6th. Do not take 3 times 4. You have to do the powers first. So 4 to the 6th power is 4,096. I used my calculator to determine that. So I'm going to take 3 times 4,096. And I get 12,288. So the already, this is growing very quickly. The 7th term is 12,288. Okay, let's look at this example. We have fractions, but that's okay. So we start by finding the common ratio. Again, they tell us that this is geometric, so we don't have to determine that first. So to find the common ratio, you take term 2, -3/8, and you divide it by term 1. Now this is a fraction divided by a fraction. There's more than one way to solve these. One way is to write this out in linear form instead of vertical, and take -3/8 divided by 3/4, and then to use your rule that says that when you are dividing fractions, you multiply the first fraction by the reciprocal of the second. So the second fraction gets flipped, and then you multiply. So this is -12/24, or -1/2. You can also cancel. 3/3 is 1. This would be 1 into 2. So you get -1/2. The other way to do this, the way I generally would do it, is I say, what is the common denominator of -3/8 and 3/4? And that's 8. So I multiply the top fraction by 8, and that cancels, and I get -3. And then I do the same thing on the bottom. I take 8 times 3/4, and that cancels, and I get 6. And of course, that also simplifies to -1/2. So our common ratio is r equals -1/2. Now, once you have the common ratio, then we're ready to write the rule. So you write out your general rule that you have written on your wall, that you've memorized, that you have in your notes, and we replace r with -1/2. Now, the first term of our sequence was 3/4, so I use that for a sub 1, and we're looking for the 9th term, so n equals 9. So you just substitute in each of those parts, and then you simplify using the order of operations, meaning that the very first thing that we're going to do is simplify the exponents. 9 minus 1 is 8. And then you must take -1/2 to the 8th power. You can use 0.5 if you want. So -0.5 to the 8th power. Now, when you take a negative number and raise it to an even exponent, you're going to get a positive number, because a negative times a negative is positive. So 1/2 to the 8th, or -1/2 to the 8th, is the same as 1/2 to the 8th, if you want to leave it like a fraction. 2 to the 8th is 256. So we really have 3/4 times 1/256, and then you can multiply those fractions and get 1/1024. Well, how come they don't get 3? It should be 3/1024, because we have 3/4 times 1/, and 4 times 256 is equal to 1024. So it really should be 3. I'm just going to double check that doesn't simplify. Nope. Okay, so 3/10,000, or 1024. In this example, oh no, this is still checking the last one. So they're just doing a few terms out, and you'll see that they got the answer of 3/1024, which I had already changed it to. Okay, so here we have number 8 on the worksheet. So if you haven't started doing your worksheet yet, this is a good time to do that. Our sequence is -7, 14, -28, 56, -112. Our first step is to find the common ratio. So the second term is 14 divided by -7 is -2. And I'll just verify, I would also get that if I took the third term divided by the second, that'd also be -2. So there's my common ratio. Let's see, a sub 1, I'm going to write it down, is -7, and n is 8. So the general rule is a sub n equals a sub 1 times r to the n minus 1. So I replace all the parts. So let's see, these are from a different problem, so I have to fix this. So I'm going to use 2 for r. For a sub 1, I'll use -7. And for n, I'm going to use 8. Did I fix them here? Yes, I did. So I plugged everything in where it belongs. And then it's very important that you follow the order of operations for simplifying, and that the first thing we do is take 8 minus 1 is 7, and then you find out what negative 2 to the 7th power is, and that one will be negative, so negative 128. So we have negative 7 times negative 128 is equal to a positive 896. Negative times negative is positive. So the 8th term of this sequence is 896.